In this segment, we'll be covering initial software setup between the VTrak D5000 and a NAS SAN client. Depending on your performance needs and budget, there are various methods of connecting your D5000. A high-performance computing environment will use 16 gigabit fiber channel host bus adapters to connect to a SAN and fully take advantage of block-level performance. Using a fiber channel connection, performance for the D5000 series tops out at 141,285 4K IOPS, 6,507 megabytes per second read, and 4,360 megabytes per second write. One step down and more budget-friendly, the D5000 can be deployed via a 10 gigabit SFP Plus network to connect to block devices via iSCSI. Using 10 gigabit iSCSI, you can expect 93,018 4K IOPS, 4,214 megabytes per second read, and 3,376 megabytes per second write. If block level access is not required, the D5000 can be used as a NAS to take advantage of the file level services. For NAS sequential performance, you can expect 42,334 4K IOPS, 3,867 megabytes per second read, and 3,525 megabytes per second write. If you're looking for higher block storage bandwidth performance, Promise recommends using the E5000 series line that can output an impressive 12,000 megabytes per second read and 6,000 megabytes per second write. For our software demo, we'll be using a SAN NAS topology configuration. We've got the VTrak D5800 RAID head, a VTrak J5800 JBOD, a 10 gigabit optical Ethernet switch, a 1 gigabit Ethernet switch for management, and a 1U server that contains a 10 gigabit SFP Plus Ethernet HBA PCI card to take advantage of iSCSI and NAS performance. This is ideal for customers that would like to take advantage of the D5000's file level services, or for customers that require block level access via iSCSI. The next step is establishing a connection with the VTrak D5000 GUI. VTrak D5000 supports Mac, Windows, and Linux. For this demo, we'll be using a browser on a Mac and a Windows host. We recommend having internet access configured on the D5000. Without it, you will not be able to do online user and product registration for the VTrak D5000. By default, the VTrak D5000 has a static IP set to 10.0.0.1 and a Class C subnet of 255.255.255.0. It's important for the workstation/server in question to also be in range to be able to manage and access the D5000. In our case, we're using DHCP IP address 10.81.50.54 with a Class C subnet of 255.255.252.0. I'm also configuring the global settings so I can get out to the internet in the event I want to register the product at a later date. As a reminder, this video only shows software setup for iSCSI and NAS. For specifics on fiber channel setup, reference the product manual and quick start guide. These are available at promise.com/support under the download center for VTrak. Now let's log in and have a look at setting up the network. Open your browser. In our case, we will enter 10.81.50.54 since our IP has already been configured using DHCP. If you get a warning, just click on Advanced, then proceed to the IP address. Promise will be releasing an SSL certificate to import into your browser. It's completely cosmetic and you can safely proceed. Login, administrator. Password, password. Now let's have a look. To set up the IP, go to Device, Network Management, Management Portal. Click on the gear icon and click Modify. From here, you can set the IP manually or use DHCP. We're using DHCP, so I'll cancel out. Now let's have a look at the global settings. Within the same section, click on Global Settings, select a floating IP, Auto DNS, since I have DHCP enabled, and enabled I/O on management ports to allow network traffic. Now let's have a look at Windows Server that'll be accessing the D5800. First, ensure the Windows Server can ping the D5000 assigned IPs. As you can see, these are statically configured. Port 1, Ethernet 8, 20.20.20.100, Class C subnet 255.255.255.0. Port 2, Ethernet 7, IP 10.10.10.100, Class C subnet 255.255.255.0. Now let's view the IPs assigned on the D5000 controller I/O portals and also look at the port speeds. This is very important. Go to Device, Network Management, I/O portal. Let's have a look at controller 1 port 1 and controller 2 port 1. Here's what we've got. Controller 1 portal 10.10.10.10, Class C subnet 255.255.255.0. You can modify the IP if needed. I'll cancel out since ours is already configured properly and in network range. Controller 2 portal 20.20.20.10. Now let's look at port speeds. Here we've got controller 1 port 1 and controller 2 port 2 negotiating at 10 gigabit speeds. Now let's open the terminal and ensure we can ping the portals from the Windows server. The next step will involve configuring the storage. We will create storage pools, assign optional SSD system memory cache, create spares, create volume, create NAS share. From the dashboard, let's click on Pool, then Create New Pool. Give it a name. Select the drive type. We will select the drives in the first enclosures, drives 1 through 23. We will use RAID 5 with a default stripe size of 64 kilobytes, and assign the pool to controller 1, then click Submit. We will do the same for the second pool on the J5800 JBOD enclosure. However, we'll assign the pool to controller 2 so we can leverage the processing power of both controllers. Now let's add optional SSD system memory cache. System memory cache comes unassigned by default. The D5800 does not ship with SSD cache, but we've installed 4 SSDs for this demo and will be assigning read and write cache to the pool. This really helps with performance. To get started, click on Cache. You notice the default system memory cache is not assigned. Click on the Create Cache button and select Read Cache. Select 2 of the 4 SSD and assign both pools to it. Next, we'll repeat the steps, but this time we'll use Write Cache and use the remaining 2 SSD. Click Submit. Lastly, let's create the spares for each pool. We will assign drive 24 of the D5800 as the revertible dedicated spare for pool 1. We'll repeat the steps for the last remaining drive 52 in the JBOD for pool 2. We're all done now. The next step is to create a volume. Click on Volume, then click on the Create New Volume. First, select the pool, then give the volume a name. Here you can also enable thin provisioning. However, we'll leave it disabled and use the maximum capacity. Leave the advanced settings default and click Submit. Default settings are recommended. Repeat the steps for the remaining pool. You're now almost done configuring the storage. In the next video, we'll cover mount and access, leveraging iSCSI and NAS connectivity. Please be sure to use the Promise Quick Install Guide and Product Manual as additional aids. Also, visit the knowledge base at kb.promise.com for additional tips.